I'm Allison Rumker.
I'm Danae Wilson.
I'm Lauren Landon.
And I'm Evan Zamora, and we are going to be taking you on a journey throughout the galaxy. This is our tour guide to the galaxy. Now, if you will hang through, we will go on and talk about our topics and the important things you'll need to know to make your way and have a good time while doing so.
I'm Allison Rumker, and today I'm going to be talking about the galaxies and the solar system. A solar system is an arrangement of planets and other small bodies around a central star. Here's the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Over here we have the galaxies. Here is a spiral galaxy. This is like our Milky Way galaxy. Here's an irregular galaxy. It's out of shape and it's got a lot of stars. And here's an elliptical where it's all spread out, as you can tell. It shines a lot. So now that we're done with that, let's turn it over to Mr. Zamora.
Alright, so I'm going to talk to you about light years. Light years are measured in meters. So 1 light year is typically about roughly 6 trillion miles. So that's also very important for you to know as you're flying through the galaxy, because 6 trillion miles tends to be a long way. So let's say you got mom and pa back home and you want to go visit them and they're 5 light years away. It's gonna take you a lot of gas to get there. So what else I'm going to talk to you about is wavelengths. Wavelengths can be used in microwaves, believe it or not, but wavelengths are measured in meters also. And the energy that's used in the wavelengths is measured in electrovolts. So you can use electrovolts to help you know how many you need, or if you're using too many, as you're traveling throughout the galaxy, because those can get pretty expensive. So the wavelengths are actually quite simple. They can look something like this, or squiggly, then straight. They can look just straight, or they can be all like this, squiggly, squiggly, squiggly. So there's different types of wavelengths also. There's microwave wavelengths, there's infrared wavelengths, there's radiation wavelengths, which radiation wavelengths, as they travel, they don't just stay in one direct path, they branch out. So it spreads as it moves. And also you want to be very careful on this stuff, because to humans and some intergalactic aliens, it is lethal at a certain percentage. So that's what I'm going to talk to you about as far as wavelengths go and light years.
Today I'm going to be telling you about the spring and neap tide. Here you can see something that a picture that I just drew. This is the spring side and this is the neap tide. Spring is the highest tide and the neap is the second highest. The spring tide occurs during the full moon and the new moon, and the neap tide occurs in the first quarter and the third quarter. Hello, back again. Today I'm going to be telling you all about the Hart-Sprung-Russell diagram. And as you can see, there are different sizes of stars and different colors. Here you can tell what color the stars are. So for instance, all the dark blue are under the dark blue, all the light blue are under the light blue. Right here, these stars are called the white dwarfs, main sequence, giants, and supergiants. This is not a map, it's location of stars. This graph is also referred to as the HR diagram or the HRD. This graph was created by me, but the original one was created in 1910. The white dwarfs are hot and bright. The main sequence stars are not hot, but they are bright. The giants are not hot and they're bright, and same goes for the supergiants. Now, here comes Lauren Landon.
The first thing we're going to be talking about is the phases of the moon. And these are all the sequence of events in the lunar cycle. So, this is new moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, third quarter, and waning crescent. The lunar cycle depends on the position of the sun and the earth. Now I'm going to be talking about the lifetime/life cycle of the star. A star first starts its life out as a nebulae. Then it becomes a star.
And a star is a globe of gas producing its own heat and light. Then it turns into a red giant. A red giant is very bright because they're so large. Then a red dwarf. They are cool, faint, and small. Now it's a white dwarf. Their mass is similar to the sun. Now a supernova is the explosive death of the star. Now it's the neutron star. And when this star explodes, it forces the protons and electrons to combine and make a neutron star. And something that's not up there is pulsars and black dwarfs, and they're a type of neutron star. Pulsars are highly magnetized and rotate at enormous speeds. And black dwarfs emit no heat or light. The last stage of a star is the black hole, and they're formed at the end of the lifetime of a star. And that's all I'm going to be talking about here today.
That concludes our Hitchhiker's Guide to the Universe.